Hello my dears. So today we are going to discuss about a very interesting topic, that is nothing but ICs. That is integrated circuit. Actually in the sub-engineer syllabus, it is a topic. Actually in the syllabus it's a topic, integrated circuit. So what they mean, or what are the points under this integrated circuit means, how can we create an IC, that means the production of IC, what are the steps in the production of an IC, and important ICs that we are commonly used in our daily life, and how can we create different components in an IC. So as an introduction we will talk about what is mean by IC. Actually there are two types of circuit, my dear. First is discrete circuits, and second one is integrated circuit. So there are two types of circuit. First is discrete circuits, and next one is integrated circuit. So what is the basic difference between this discrete circuit and integrated circuit? In the discrete circuit, it is similar to that we are doing some experiment in our breadboard. That is an example of discrete circuit. Or we are doing some circuit, we are creating some circuit on PCB printed circuit board. That is also an example of discrete circuit. That means each component can be distinguishable, each component can be replaceable. We can add a new component, we can solder it manually. That type of circuit is called the discrete circuit. So commonly we are seeing in before 1950s, 60s and all, we used discrete circuit. So what are the disadvantages of this discrete circuit? The discrete circuit is actually bulky in nature. Even though we have to create a simple low pass filter, we need a breadboard, we need a PCB on which we have to solder everything, and the component size is very big. The resistor, capacitor, everything is big actually. So there is a lot of disadvantages in discrete circuit, also a lot of advantages also. And the main disadvantage is nothing but, my dear, the bulkiness, the space requirement of the component. So we have to make a particular, we need a particular space for every component. That is the main disadvantage or drawback of the discrete circuit. And the advantage is very simple, my dear. Even if a resistor or a capacitor is problematic, we can replace that, and we can replace with a new one, and the system will continue to work. Next classification is integrated circuit. So what is mean by integrated? Integrated means every component is integrated into a single chip or single circuit is called the integrated circuit. Okay, so integrated circuit have a very it is very popular nowadays. ICs, you know this, and it has a lot of advantages. The first advantage is that the space requirement is very less. For simple IC, just the size of an IC is very small, right? In the centimeter range it actually occurs. So the size is very small, so the less space requirement. And the next advantage is what? The cost is very less. Suppose we are going for a discrete component, resistor, inductor, capacitor, everything you have to buy, it cost. PCB you have to buy, it again cost. Soldering iron you have to buy, it again cost. So the overall cost of the system will be very high. But in the case of integrated circuit, total chip will be at this range. So the cost is very less, and the power requirement, my dear, it is very less. The power requirement is very less, and also these integrated circuits can operate in wide range of temperature, or extreme low and extreme high also. That easily it can be operated. And of course I already told you the cost is very less compared to, and the space requirement is very less, and there is no projecting components in an IC. You can't see any projecting components there. That means the system is very neat and clean. The system is very reliable. The system is very neat and clean. So there is no projecting components over the package. So it is very tidy and the compact in size. Okay, so ICs are very commonly used nowadays. So now we have to discuss some drawbacks of ICs also. The main drawback of IC is nothing but, even if a small component, a resistor or inductor. So what is mean by IC? Again, I want to tell you what is mean by IC. It is nothing but a circuit in which we integrated resistor, inductor, not inductor, resistor, capacitor, diodes. Resistor, capacitor, diodes. Okay, and its combinational circuitry, everything we can integrated into a single chip is called IC. Okay, so the main drawback of this IC is nothing but, my dear, if any problem in one component happens, suppose a resistor is problematic, then the entire IC we have to change. We cannot individually repair a component. We cannot individually take resistor and replace it with a new. That is the main drawback of IC. If one compare goes wrong, the system or the IC you have to replace. And next disadvantages of our IC is that we cannot make transformers, inductors, very important inductors. We cannot make these two. Transformers you can't make in an IC, and inductors you can't make in an IC. That should be always external to the IC you can connect. Transformers and inductor. Okay, capacitance, diode, resistor, everything you can make, but transformers and inductor you can't make. That is very important point. And the power requirement, my dear, the power requirement, not greater than 10 watt you can't make. Not greater than 10 watt in an IC you can't make. 10 watt IC is maximum. More wattage ICs are not available. So greater than 10 watt is quite difficult to manufacture, or it is impossible. And the capacitor value greater than 30 picofarad is very difficult to create. You can maximum create up to 30 picofarad of capacitance, but beyond that it is impossible. It is almost impossible to create greater than 30 picofarad capacitor. So these are some disadvantages of an IC. But even though you can create an external capacitor, no problem. You can add one. The power requirement is very less now, so you can add some adjustment circuitry to overcome this power requirement and all. No problem. Okay, you can step down, and again you can use the IC. Again you can step it up, and you can use. Okay, and also you can high power devices also available in the market now. You can use that also. Okay. So these are the overview of an IC. So now we are going to discuss how can an IC created, or what are the steps in the production of an IC. So for competitive examination point of view, my dears, the steps now, each steps contain some specific terms. So that terms you have to note down, and that may be asked. Okay. So let's discuss what are the steps in the production of an IC. What are the steps in the production of an IC? First step is nothing but P substrate. P substrate. P substrate is nothing but, my dear, you have to take a P-type silicon and allow it to grow to 25 centimeter of length and 2.5 centimeter of diameter and 2.5 centimeter of diameter. And by using a diamond knife, or a diamond knife or diamond sword, you can say, you have to cut it. You can cut it into wafers of thickness 200 micrometer. 200 micrometer. This is nothing but, my dear, 2.5 centimeter. There is no change in that. So the first step to produce an IC is nothing but we have to take a basement. We have to create a basement. Now, if you are going to build a house, you have to, first step is you have to make a basement. So similar manner, for everything to be installed, you have a base, right? So that base is nothing but P substrate. How can that P substrate is formed? Simply by taking a P-type silicon. A P-type silicon you have to take and allow to grow it to a length of 25 centimeter and 2.5 centimeter diameter, and slice this 25 centimeter into small wafers, small wafers, and each wafers can have a thickness of 200 micrometer. 200 micrometer. Is it clear? Is it clear, my dear? So there you can create a P substrate. So this is the basement of the IC. This is the basement of the IC. Okay. So that is can be, you can sword. I mean, you can slice it with the diamond sword or diamond knife. Diamond knife is there. You can cut it into small pieces, because silicon, you know that it is like a glass, right? A type of glass. Now silicon is the base of glass. So for cutting glass, we need a diamond knife. Diamond knife. So diamond knife, you can cut it into a thickness of 200 micrometer. 200 micrometer. So that is the first step, my dear. That is the first step of making wafer. So this is called the wafer. And the second step is nothing but epitaxial N layer. So next step is nothing but, my dear, epitaxial N layer. What is that? Epitaxial N layer. So epitaxial N layer is nothing but, my dear, so over this P substrate, you have to add. So this is the P substrate now. P substrate. You have to add N layer. That is, you have to add an N-type material having a thickness nearly 10 micrometer. 10 micrometer. This is already, this thickness is nothing but, my dears, what is it? 200 micrometer. So above that you have to add a pentavalent impurity. Simply it will make an N-type, right? You have a P substrate, fine, okay. Now you have a P, same silicon you can take, add N-type impurity, it will convert like what? N-type layer, that's all. You have to add an N-type layer above the P substrate of 10 micrometer thickness. This will form, this is called the epitaxial N layer. This is called what, my dear? Epitaxial N layer. And the third step is nothing but insulation. The insulation. That means the epitaxial N layer, this should be insulated properly to avoid a contamination by the atmospheric vapor, dust, etc. We have to insulate it, right? We have to insulate it. So this is our P-type substrate, and this is our N layer. This is P substrate. This is N layer, and you have to insulate it, my dear. You have to insulate it. This insulation, this is made with SiO2. So how can we make the insulation? How can we make the SiO2 insulation? Silicon is already there now. N is already layer. That is nothing but silicon. You have to diffuse it, or you have to apply some oxygen at very high temperature over the N layer. It will form what, my dear? Silicon dioxide insulation layer, SiO2 layer. So that is a simple way you can add the SiO2. You add the SiO2 layer over the what, N type layer or N epitaxial layer. Okay. Next, you can add by, next is nothing but etching. Next process is etching. This is very important process. So etching is nothing but, my dear, So this is our substrate. N insulation. This is N and this is P substrate. So this is SiO2. So etching is nothing but, my dear, it is a process of exposing a particular region in the N layer, so that through that exposure or through that drill or through that hole we can make the leads of the component. Okay, it will be more and more clear when we are dealing with how can we produce each component in an IC. Then it will be more and more clear to you. But until now, or from this knowledge, you just remember one thing: etching is the process of drilling over this SiO2 layer. That means you have to drill, my dear, nothing. Suppose here you want to create a component. You imagine here you want to create a resistor. You imagine. So how can we create that resistor layer? Simply you can drill a portion of for resistor 2 leads we need now. 2 leads we need. So how can we produce lead? Drill here, drill over this SiO2 layer, drill again over this region and connect here. So this drilling is called the etching. So etching is nothing but, my dear, it is a very important step in the production of an IC. So we have to expose this N layer, so that we have to make component, we have to make external connections. Okay, we have to make external leads, so that we have to drill a particular portion in the N layer, and that also through SiO2 layer. That also through SiO2 layer is called the etching process. Okay, is it clear? And the fourth step producing components. The fourth step is producing component. Simple, but you have to make the component, and how this component is creating we will discuss in very detail in the next lectures. Okay, how can we make individual component there? Okay, so until then, etching after component production, and the final step is nothing but chips. That means the entire wafers, now we have entire wafers like this. The entire wafers divided into small areas. This area is called a chip. This area is called a chip. So many chips are there. So many chips are there to form an IC. So the whole IC, the whole part of the IC contains so many components, my dear. Each component is actually over a particular area, and these interconnections are there. So this is called a chip. Okay, so chip is nothing but a very small portion. IC is nothing but so many chips are interconnected in order to form an IC. So the least or very smallest region in an IC is called the chip. The smallest region in an IC is called the chip. Okay, so chips are nothing but the whole IC is divided into smaller area. The smallest area of an IC is called the chip. These chips are interconnected. Here you can connect resistor, capacitor, again diodes. These connections are made inside. Okay, each area is specifically for a component. Okay, a component. So that is called a chip. Is it clear, my dear? So that are the steps involved in the production of an IC. So in the next class we will discuss about how can we integrate components. You have now a doubt that, Hari sir, how can we introduce resistor there? How can we introduce diodes there? You have a doubt now? That we will clear in the next classes. Okay, so until then, bye.